So in this lab, we are going to build a half-wave rectifier with a capacitive filter. The first circuit we're going to build is we're going to hook our LED up to an AC sine wave, the 1 kilo ohm resistor. So we are going to build this first circuit right here. You see that at the top? So I'm going to reconfigure this and to move that here. And we'll hook this up here. Now we'll see that it is now, our LED is hooked up in this configuration here. So it is hooked up just like this with our generator, a 1 kilo ohm resistor, an LED, and ground. That's the configuration I have it in now. The reason it is pulsing is because we are feeding it an AC sine wave, which I can adjust over here. So if I want to increase the frequency, I can slow it down because it's on our clock generator. So we're hooked up from the clock to ground through that circuit. And if I want to adjust it, I can speed it up. If I want to adjust the frequency up even more, I can, as I increase the frequency hertz, see how it flickers more and more. Now, this isn't really good for an LED. They're not really meant to work on an AC voltage. What it is when the positive half of that alternation happens, it's activating this LED, and when it drops to the negative half, it blocks the current flow, which means it doesn't light up. It works on DC. But right now it's hooked up to AC, so it's flickering. Well, we know that's not good for power supply. What we want is a smooth DC voltage, and that's what we're going to do is build a rectifier. So the first thing we got to do is get rid of the negative half of our sine wave. And what we're going to do to get rid of the negative half of our sine wave is we are going to use a diode. A diode, if we look at the symbol on a diode, let me come over here to different view. If we look at the symbol on our diode, we will see that the symbol for an LED has the little light rays coming out, and the symbol for a diode here is the same symbol. So the symbol for a diode is the same except for the light ray. And so there is a polarity for these diodes, and so you'll get a diode out of your kit. I don't really see the number on these, and it probably doesn't matter. Let's see, the number on this one out of your kit would probably be, it'll be the heavy duty one. Let's see if we can identify that number off this diode in your kit. Somebody with good eyes, read the number off this diode. You can read that. 4001. 4001 is what it says. But basically, any of the diodes in your kit will work at this low voltage. So just pick one of your diodes. Notice that it has a band on it, and that band determines the direction of flow. It only lets current flow one way through this band. So what we're going to do now is we're going to add the second part. We're going to insert the diode into our circuit and cut off this sine wave. So we only want half of the sine wave. Everybody with me so far? Yes, sir. All right. So instead of power coming across here, I'm going to disconnect the power jumper here. And in its place, I'm going to put this diode going to the resistor. And we don't really see any difference because the LED is a diode. And so it doesn't look any difference right now. But let's look at the sine wave. So I'm going to move my oscilloscope probe past the diode, and let's come over here and look at our sine wave. Here we'll see that we've actually only have half a sine wave and that we're cutting it off. Before we had the entire sine wave. See how it's cut off now? So we only have the positive alternation coming through. The rest is blocked. We still have a flickering LED. If you're looking for some reference in your book, on page 425, figure 9-54, this is what we're building. We're going to add a rectifier. We've added that by using our diode. We're going to add a way to filter out the ripple. Basically, we're going to charge a capacitor, and when it gets to this gap right here, the capacitor will discharge, filling in the gap for us, and we will get a smoother, pure DC sine wave. We will still see a little ripple in it. And so what we're going to be shooting for is this figure here. This is our diagram, our last diagram that we were shooting for right here. So now I want to go ahead and add a capacitor. Which capacitor do we want to add? We don't know. But with this small amount of voltage, because if we look on our measurement here, we are only doing 328 millivolts. So we're hardly doing any voltage peak to peak here. So we're not doing a lot. So we can pretty much have the run of anything we want to put in this circuit. It's not a real current intensive circuit or high voltage. So what we're going to do here is play with different capacitors and see what they do. So I have some miscellaneous capacitors out of my kit, and I'm going to insert them into the circuit and watch the AC waveform. So let's go back to our other view. So I'm going to take this large capacitor here. I believe this one is a 100 microfarad, and I'm going to insert it to ground on the other side of this resistor. So before it comes in there, so I'm going to go ahead and insert that, and all that's going to do is begin charging up and discharging into our circuit. Notice that our light now it's still got some flicker, right? It's still flickering, but not like it was. Okay. If I were to increase the frequency, we could see it get worse and better as the time constant changes. So I can modify the frequency a little bit. But let's look at our AC sine wave with this capacitive filter installed in our half-wave rectifier. And so here is the waveform, a lot smoother, right? So let's look at it without the capacitor. I'm going to remove the capacitor, and it goes back. And our light's flickering. And then we're going to put it back in here. So for your project, I want you to hook up this circuit and try different value capacitors and watch the AC waveform. So